Next problem, type 1, reframe the table, right? So there are three typists working on an office. The times given in minutes they spend for the tea break, in addition to the allowed lunch break, are observed and noted below. Can the difference in average times that the three typists spend for the tea break be attributed to chance variation, right? So given tabulated value of f, 5% level of significance, degrees of freedom 22,2 is 19.45. So we'll see the solution. So let us reframe the table. So draw the table. Typist, so they are in the row R is equal to 3 treatments A, B, C, and the time spent for tea break. So C is having the most number of time, right? So it is C has the most number of time in the data, right? Given data, right? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So make it 10 blocks, right? 3, 4, 5, 6, 7, 8, 9, 10. So write the time spent. A, right? 25, 18, 30, 32, 35, 37, 19. B, 24, 22, 26, 28, 30, 32, 28, 26. Then C, 28, 20, 27, 19, 29, 35, 30, 23, 27, 32. Then you have to write the C, right? C, number of columns. A has 6, 7, right? Yeah. And B has 8 and C has 10. So C1 equal to 7, C2 equal to 8 and C3 equal to 10. So given data, so number of items 25, so capital N is equal to 25. So number of treatments are row 3 and Ci, number of samples, right? So C1, C2, C3 not equal, they are equal to C1 equal to 7, C2 equal to 8, C3 equal to 10. Next, define the hypothesis. Null hypothesis, there is no significant difference, right, between the three typists. Alternate hypothesis, definitely there is a significant difference between the average break time for three typists, right? So first calculation for ANOVA table 1. So typist R is equal to 3, A, B, C. Then break time, right? So number of blocks 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A value, right? Then B value. Then C value, right? From the reformed table, right? Previous table. Then we have to find row total R1, R2, R3. So first row total 25 plus 18 plus 30 plus etc plus 19. So R1 equal to 196. Then second row total R2 24 plus 22, that is the B values, right? Second row 24 plus 22 plus 26 plus 28 etc you will get 216. Then third row total, so C values, right? 28 plus 20 plus 27 plus etc up to 32, 270. Then adding all RIs, right? Summation RI, that is nothing but grand total G. G is equal to summation RI is equal to 682. Next you have to find RI by CI. So you have to divide each RI with the corresponding CI. So R1 by C1, R1 square by C1. Square the RI square R corresponding RI with its number of columns with its CI, right? So square RI square by CI. So R1 square by C1. So 196 square by 7, 5488, and R2 square by C2, 216 square by 8, 5832, then R3 square by C3, 270 square by 10, 7290. Then adding up all these things in this particular column, you will get summation Ri square by Ca, that is equal to 18610, right? Next you have to find the sum of squares of each item. So first row, in the first row, sum of the item, sum of the square of the item in the first row, that is in the A values, right? 25 square, 18 square plus 30 square plus 32 square, right? So first summation xij square, that is equal to 5828. Similarly second row, B values, square and add up, 24 square, 22 square, etc, etc, you will get 5904. Then third one, so 28 square, 20 square plus 27 square plus 19 square plus etc, etc, you will get 7522. So adding all the sum of squares, you will get total sum of square of this data, right? Yes, that is equal to summation xij square, that is equal to 19254. This is this total, right? Sum of square of the given data, right? Next correction factor formula, g square by n. G we know, that is 682, square by n we know 25, so you will get 18604.96. then we have to find the total sum of square, right? That sum of square is table sum of square, right? So now we are going to find the total sum of square, which we are going to use in the ANOVA table, right? So because the correction is there, no, so you have to subtract that correction, that is why CF. So total sum of square is equal to SS minus CF, so that is equal to 19254 minus 18604.96, so 649.04. Next sum of square between the sample BSS. So formula is summation Ri square by Ci minus correction factor. So you will get 18610 minus 1860.96 for 5.04. Next sum of squares within the sample WSS, TSS minus BSS. 694.04 minus 5.04, 644. Then you prepare the ANOVA table. Source of variation between sample and within sample, sum of squares, BSS between sample sum of square 5.04, within sample sum of square 644. Next corresponding degrees of freedom between sample, that is V1 is R minus 1, so 3 minus 1, that is equal to 2. Then within sample n minus r, V2 is equal to n minus r, n25 minus 3, that is equal to 22. Next mean sum of square. So mean sum of square between the sample MBSS, that is equal to BSS by V1 formula. So BSS we know 5.04 by 2, 2.52. Then mean sum of square within samples. So MWSS, that is equal to WSS by V2, 644 by 22, 29.273. Right? Here MWSS is more than MBSS. So when you are writing the F formula, first write MWSS in the numerator and MBSS in the denominator, right? Next F ratio, FC is equal to, right, MWSS by MBSS, because MWSS is more than MBSS. So 29.273 by 2.52, that is equal to 11.616. So calculated value is 11.616. Now we have to compare with the tabulated value to get the conclusion. So degrees of freedom V to V1, right, according to that, highest one and lowest one, comma the lowest one, 22 comma 2. So tabulated value given, that is 19.45. So calculated value 11.616. So calculated value is less than tabulated value, therefore H0 is accepted, right? That is the conclusion. So there is no difference among the average break times for the 3 typists.